Hello, this is Ankit Alex Hansta. We are 15 so it's 258 and I'm making this video to explain about the program that I've made for data structure lab. Uh, the aim of this experiment is implementation of linear and binary search. So first we will be doing linear search. Linear search is the simplest form of searching any element in a group of elements, that is array or linked lists. So in this we compare the searched element to be searched element with each element of the array and continue till continue the iteration till it's found. uh, it has a higher time complexity compared to other methods, but it is simplest. So moving on to the program, first we will include the required header files. Then we'll move on to the main function. In this main function, first I have uh, like declare the element, that is arrays, which will store the list of elements, and that is size of the array. S is the element to be searched. C here is used as a flag, which will mark whether the element is found in the list or not, and ing is for arrays. So first this part is to input the element into the list, and these elements are we get this input from the user, and we move on, and then we search using this simple algorithm, that is we'll run a loop throughout the element and check out the condition if the element at position I is equals to S, that is the element to be searched. If it is present, then it prints out the element is found in the location, and if it is not, then it prints out that the then C is not incremented and C remains 0. So if this condition, if C is less than 0 or is 0, then the element is not found from this file. So let's try this program. There will be 5 elements. So let's try searching 3. As you can see, we found it, that it's in location 2. If we try again, and try searching some other element, it shows that element is not found. So we have successfully implemented linear search. Now moving on to binary search. Binary search has a time complexity lesser than the linear search, and it works on a principle that on the method that we first divide the list into two parts, and the middle part and the middle element, we compare it with the element to be searched, and before searching, the list is supposed to be in sorted manner, that is it should be in ascending order, then only we can implement binary search. So when we divide and and we compare the search element with the middle element, if the middle element is the element to be searched, we return its position, but if it's not, then we move to the part, then we compare it. If the middle part is less than, if the searched part is less than the middle part, then we move towards the left side of the list, but if it is larger than the middle part, then we move to the right of the list, and we continue this method of dividing and comparing with the middle one until it's found. But if it is not found, then we print that the element is not found. So for that we have like included the required header files, and in main function I have initialized the lists and the required variables. In this part I have inputted get the input from the user and and this part is to like tell whether the list is empty or not. And next we have we will ask the user to input the data in sorted manner. uh, Now for the searching part, as you can see, we will start a while loop, and we will take the middle position to be m, and we'll find the middle part and check whether if the middle part is the element or not. If it is if the middle one is the element to be searched, then we will print out. But if it is not, then we will compare whether the search element is greater than middle element, or search to be element is greater than middle element or not. If it is greater, then we will move to the right side, but if it is smaller, then it will move to the left side. So for that we will change the rear and front part, and respectively, and repeat this loop until r is less than f, that is until front becomes less than or equal to less than rear. That is only one element is left, and it cannot be divided anymore. And if we find it, the program will print the location, but if we cannot find it, it will print element not found. So let's try with an example. So let there be 5 elements. We search 5. As you can see, element is found at location 4. So our program is running perfectly. So thank you.